7.1, we're going to talk about prime factorization, and first we need to go through some definitions. Our first definition is when two numbers are multiplied together, each number is called a factor of the product, and the product is the answer to a multiplication problem. So if I said 5 times 2 equals 10, my product is 10, and 5 and 2 are both factors. So when a whole number has exactly two factors, it's called a prime number. A prime number also must be greater than 1. So that means 1 cannot be a prime number. When a whole number is greater than 1 and has more than two factors, it's called a composite number. So now we know what prime and factor mean. If we use prime factorization, or factoring, this expresses a number as a product of its prime factors. So if we look at a monomial in a factored form, when it is expressed as the product of prime numbers and variables, and no variable has an exponent, greater than 1. That is when it's in factored form. So let's look at some examples factoring using prime factorization. So our example says factor each monomial using factorization. Remember, monomial means we've got one term, and look at number 1, 20, that is one term. So to factor, we have to break it down into two numbers that multiply to give me 20. If I did 2 times 10, that would give me 20. Now this 2 here, my 2 is prime. It's greater than 1, and the only two numbers I can multiply together to give me 2 are 2 and 1. So this number is prime. So I'm going to circle it because I know I'm done with this branch. Now 10, that's not prime because I can multiply 10, or to get 10, I can multiply 2 times 5. 2, we know that's prime. Only thing I can multiply to get 2 is 1 and 2. And same thing with 5. The only thing I can multiply to give me 5 is 1 and 5. So now my 20 is broken up into 2 times 2 times 5. This is my prime factorization. I expressed my number as a product of its prime factors. If you type in 2 times 2 times 5 into your calculator, that's going to give you 20, so that's a good way to check. And none of these numbers, my 2's and 5, cannot be broken down any further. We call this a factor tree. You can see that these lines are kind of like the branches of our factor tree. And so that's another term that you'll hear often. So let's look at number 2. If we break number 2 up, negative 45, well, to get that negative out of the way, negative 1 and 45 gives me negative 45. So my negative 1, I can't break that up any further. But 45, I can break that into a 5 and a 9. 5 is as far down as it can go. Only thing that gives me 5 is 1 and 5, but 9, I can break that up into 3 and 3. Again, 3's, can't break those up any further, so that's the end of my factor tree. Now my last step is to write all my factors out. I've got -1 times 5 times 3 times 3. Okay, now let's look at some examples with variables. So if we break this down, I can break my 12, let's just look at my constant first. I can break my 12 into 2 and 6. 2 is a prime number, can't break that anymore, but 6, I could break that into 2 and 3. Okay, so now I have my 12 factored out. That would be 2 times 2 times 3. And then for the variables, what I'm going to do is just write each variable without the exponent. So if I have x squared, that means I have a times a. 2 a's multiplied together. And then b by itself is just b. So I'm just breaking apart my monomial. Okay, number 4, let's break our 25 to start into -1 and 25. So that -1 can't be broken down any further, but 25 can be multiplied by 5 and 5. So now I've got -1 times 5 times 5, and my y, there's just one of those, but my z is z to the third, so I'm going to have 3 z's multiplied together. Okay, number 5, 5a. My 5 is already broken down. 1 and 5 is as simple as it gets. So my prime factorization is just 5 times a. It's already prime. Number 6, 24, can be broken into 2 and 12. 2 is as low as I can get, but 12 can be broken into 2 and 6. 6 can be broken into 2 and 3. Okay, so I've got 3 2's and a 3. Then I've got 2 a's, 3 b's, and 1 c. And that is my prime factorization for number 6.